Good. Then, yeah, I simply start and talk about our action grammar project, which is, so it continues our work in the direction of higher cognition. And it's meant to be our first step into the direction of action planning and also problem solving. And as Jan already hinted at, it's based on his work on intentional states. So this is still an ongoing project, and I just want to give you an idea about what we're working on in this project right now. So as a motivation, we would like to have a representation of an action repertoire that we already learned and that we now can use to ground these actions, so to perform those actions in new scenes. So as some examples, when you're all able to make a cup of coffee, right? And you know how to do it, even if it's the first time you're using the coffee machine in the office. It may take you a little bit longer to figure out like where to put the coffee beans or the water, but in the end, you figure it out, right? So also you can start a new car or your friend's car. You can play computer games by using the same controller for various games, and you're quickly able to figure out how to use those buttons on the controller to play a new game. Then when you're cooking or preparing food, this is actually a very complex kind of action because you're doing a lot of it in parallel. So you're maybe washing the salad and then cutting the tomato, getting something out of the fridge. So you probably never do it exactly in the same way twice. And then we have children's game. So as an example, this is the so-called Tony speaker, where children can put those little figures on top of the speaker. And then the speaker will play some music or an audiobook that is connected to this figure. So what we would like to have is an action grammar that generates all those different kinds of actions. And the approach we took is inspired by Paistra and Aloimonos, and what they called a minimalist grammar of action. And they used this action grammar for passing actions from videos. So they tried to guess an action goal. And we now use a similar structure, but we do it like the other way around. When we have a goal in mind, we would like to generate the corresponding action. So, and what they did is they defined action roles that classify such a structure of a grammar. And yeah, we did the same. So we have an agent, which is the subject that is acting in the scene. We have the action itself, which is like when you have a sentence, it would be the verb of the sentence, like coffee making or slicing an apple, pressing a button. We have then the tool, which is either the body part effector that is used to perform an action, or like an extension of this effector, which is then usually an object, which is also used as a tool. So for a body part, this would be your hand or maybe a foot, and an object-like tool would be something like a knife. Then we have the affected object, which is the object the action is directed at, and it's also usually the object that changes its state somehow during the action. So the apple that is cut into pieces, the button that is pressed, and the speaker that then plays some music. And we may have a modifier. This comes from Paistra and Aloimonos, and they used it to specify the scene. So you usually cook in the kitchen, or you think about like starting your car when you're sitting in it. And of course, we have the outcome, which is then the change in the world, what happens in the world. And this is also often the goal of an action. So that you get your cup of coffee, that you have the apple pieces, or the music that is playing. So those action roles now give meaning to our process models. So this is similar to the idea of reference and target object roles that you learned about in spatial language. Okay, and this is the scenario that Jan presented in his talk, and we can find all those roles here as well. So we have the agent, which is of course the robot that is acting in the scene. And we have the action painting, which is actually the sequence of action of moving around, collecting color, then move again and apply the color to the canvas object. And as a tool, we then have either the end effector of the robot when it collects the color, or it's the collected color that is now used to change the color of the canvas. And as an affected object, we have, of course, the canvas that then changes its color, but also the code color that may be collected by the robot. And so in this scenario, we would not specify a modifier because the robot only lives in this one world and it only does painting. So yeah, and of course we have the outcome, which is the change of the canvas color or the state that now the code color is collected, or simply being at a new position. And so when the robot moves around. Okay, so now with all those action roles, what about the action grammar? So with the action roles, we now would like to generate a sequence of those actions, like the robot moving, collecting color, and so on, that then leads to the desired state in the world, so to the goal state we have in mind. And by this, the action grammar is like the structure between the intentional modes that Jan introduces, and it helps communicating between like the perception and the belief and the intention and action modes. And what we would like the action grammar to do is that it should be applicable for different actions and also different tools and objects and in new scenes, of course. So, and because it should be able to do this, it should also guide the grounding of those objects in the current scene. And it would also be nice if there's some flexibility when something goes wrong. So, but only in a limited way. So in a sense that imagine that the robot drops its color on its way to the canvas, then we would like it to go back and pick the color up again instead of trying to apply it now to the canvas, right? Good. So to investigate such an action grammar, we changed the scenario to get a more richer environment. So we now have a robotic arm that can move around in 3D space, and it can pick up those little objects, figures you can see on the table by using this ball-like structure, which is a connector. So it's like an electromagnet so that those little figures are simply sticking to this ball. So the robot can move around and pick up those objects. And when it then places one figure on top of the larger box here, this box plays some music. So it's actually a Tony speaker like that I showed you on my first slide. So this is the first action the robot is able to do, which involves like a tool. So think about the figure that is placed on top of the speaker as being the tool to operate the speaker in a specific way. And another object where the end effector of the robot is used as a tool is pressing this button here. And this button then changes color. So from red to green and from green to red. So later we may use this as a power button in a more complex world. Maybe the robot needs to like press the button first to switch the speaker on before it can place the figure on top of it. So to have a more complex scenario. But for now, we have two distinct and different types of actions, one involving an object-like tool and the other the end effector as a body part tool. Okay, and also all objects are now defined by color and shape and by their size. So yeah, that we have like richer feature dimensions. And now this is the overview of the intentional states architecture. So this is a similar illustration, a figure that Jan showed you in his talk. But it's now extended for the new tabletop scenario. So we have the sensory motor surface, where now we have like the arm models that can now move in 3D space. We also have a microphone for detecting the sound that the speaker makes. We have a sensor and also a motor for the connector, so that we know what kind of object we have in hand and we can lock and unlock those objects. Then the connector also has a touch sensor. And yeah, now we have like a scene representation for three features: color, shape, and height, and also our memory here. And of course, we have a different set of intentions and actions, and those here are the intentions and actions that directly are coupled to the sensory motor surface, like locking or dropping an object or moving the arm. So those are like primitive intentions and actions. And what you see here are sequences of intentions and actions, like grasping, which is a sequence then of moving down to the object, locking the connector, and move up again. So Jan called this prior intention, but we now call it like sequence or more complex intentions and actions. And as a belief structure, we now have not these color rules that Jan showed you, but we use a set of those action roles to represent action phrases. So yeah, let's take a look at, first, so the action grammar is now what like connects all those different intentional modes. And so think about it being the background between those. And the connection now is being then in such a meaningful way that we can then generate goal-directed behavior. Okay, so now let's take a look at the representation of such an action phrase. And for this, we use the belief structure that Jan showed in his talk a few minutes ago. So an action phrase is now a set of the action roles. So in this case, it's the robot that places a red cross figure on top of the speaker box to get some music. And this action phrase is already learned and therefore connected by this label node here. So this label node now points at those different concepts, and these concepts live in such concept pools where those concepts that are typical for that action role are grouped together. So in the tool concept pool, you would find like body part concepts, like your hand or your foot, but also smaller objects like the red cross figure that can be picked up and then used as a tool. And in case of the affected object, you will also find larger objects like the speaker. And in the action pool, there are only those concept nodes that represent an actual action, which is then eventually connected to the motor surface. So you wouldn't expect to find an object there, right? Okay, so for the object-like concept nodes, those are now connected to their features. So the red cross is something like red with a cross shape and a small height, because this is something we can pick up. So every concept node here is kind of a belief, has kind of a belief structure itself. So this being the belief about something with these three features seems to be the red cross that I can pick up and then place it on the speaker to get some music playing. And so we have the same for the speaker, and for the music we would then expect an outcome change in the dimension of music. So what's important is that all those concept nodes are always connected to the sensory or motor surface. So in case of the objects, it's the sensory surface, and in case of the action, it's the motor surface. So yeah, this is a different kind of action. So this would be now the robot using the end effector to press the red button, and then we have a change in color so that we get a green button. And now for the arm, we would not have such color, shape, and height features, but we would have like a body part representation that the robot knows what part of its body is the arm. Good. So the action phrases are still activated by having a goal representation that then activates the outcome concept nodes. And when then an action is learned, because all those connections here are bidirectional, the outcome concept node would now activate the corresponding label node. So in Jan's talk, these were the belief nodes. And then all other missing concept nodes can be recalled through the bidirectional connections once the label node is activated. Okay, so now let's take a look once this action phrase was activated, how the action concept is connected to the model surface. And in the example of pressing the button, this concept node would be connected to the more complex sequence of intentions and actions of pressing, which is moving the arm down until it touches the button. Then we would have a condition of satisfaction for that movement. And then the next part of the action sequence is activated, which is in this case simply move the arm up again. And then we would have a condition of satisfaction for the whole action sequence. So we assume that those more complex sequences of intentions and actions are already learned and they have a fixed order. But then the condition of satisfaction may vary depending on the higher level action. So here we would think about this as being the prior intention. So when you have an action plan mentally that you would like to press the red button, and once also the sequence of intention and action is activated, the robot would start to move, so that we have so that we can differentiate between the that we would like to act and that we react. So this is a slightly different use of the terms of intention and action and prior intention that Jan used in his talk. So because we would only like to activate the intention and action when the red button is actually in the scene and maybe the arm is already close to the red button. So we have some preconditions that we need to fulfill first before we would like to activate the sequence of intention and action and start to generate movement. And those preconditions are defined by the object-like action roles. So when we have a tool and it's an object, we would like to have this tool in hand first before we start our action using this tool, right? And in the other case, when we want to use the end effector, our hand or the connector as a tool, we would like to have a free hand and nothing else. Yeah, in the case of the robot sticking to the connector. And then we have also the affected object, which should, of course, be in scene, like the tool itself. And the tool or the effector that is used should be close to the affected object before we start the action itself. So those preconditions are the same states that we would use to identify tool and affected objects when we pass actions or when we do imitation learning, right? So when you try to guess what someone is doing and he has something in hand, so he might use it as a tool. Okay, so now those preconditions are new desired states in the world that we would like to achieve. So they are new sub-goals of the activated action phrase. And for those new sub-goals, we know that there are other actions that we can activate to achieve those desired outcomes. So in case of the tool object, simply grasp it with your hand. And what here typically happens is that the tool object now becomes the affected object in a lower level action. So you're now using your hand as a tool to grasp the object, which is then later used as a tool itself. And now we have new preconditions, so that we need the free hand to grasp the tool, and the hand should be close to the tool. So we get an action tree with the activated complex action phrase on top, and then the sub-goals and sub-actions on different levels and different branches of this tree. And in our scenario, we only have this one effector, so nothing can be done in parallel. And this is why we can represent this action tree completely. And this looks like this. So we have here the belief structure, and then we have the action grammar hierarchy here, and then our perception and intentions in action. And you're not supposed to understand this completely now. I just want to give you a quick overview about the main concepts. So we have now the tool and the object action roles in our higher level action that we would like to generate. And those give us the new preconditions, so 2 sub-goals on the first level. And for those, we know that there are 2 actions to achieve those goals. So this is maybe grasping the tool and moving to the position of the affected object. And then this goes on, like we have new sub-goals and then again new action phrases. But what's typical is that now the tool, as I said, changes its role to the affected object. So we need to pass these arguments to the second level, to the correct position, now being the affected object instead of the tool. Good. So at each of these levels, all preconditions must be fulfilled first before the intention in action can be activated. So this would be fulfill those 2 preconditions first, and then we can activate the intention in action. Also, at each of those levels, only one goal state is active, so that we are only activate one part of this action tree at a time, and this prevents that several intentions and actions are done like in parallel with only one effector. And once the intention and action is performed, we have an expected outcome and a change in the world, and if those match, the condition of satisfaction is activated for the corresponding action phrase. And once that happens, the condition of satisfaction now inhibits the lower level of action phrases or intentions and actions, like here or here. so that we can go a level up in our action tree or even switch the branch until we eventually are able to perform the action here on top. Okay. And now I would like to show you this in some videos. So here we have the robot that now picks up the red cross figure and places it on top of the speaker box using this kind of action grammar structure. Good. So here everything is fine, but what happens if, oh, sorry. So here I forced now the robot in the simulation to drop the figure on its way to the speaker. And at each of those levels, all preconditions must be fulfilled before the intention in action can be activated. So, okay, so the robot didn't recognize the object being upside down. So instead of now try to place the object that is not in its hand anymore, it will go back and pick it up again. And now I think it drops it again. Yeah, almost. Good. And as a last action, we would have simply pressing the button to get the color changed. So yeah. So we can generate both actions using this action grammar. So now I'm almost out of time, and I want to summarize. Our motivation was that we can represent a repertoire of learned actions and then generate a sequence of actions. And we represent those action phrases now as a set of action roles using the belief structure that Jan introduced in his talk. So the action roles now define preconditions that must be fulfilled first before the action then can be performed in the scene. And those preconditions activate new goal states, or are instead new goal states that then point to those new sub-action phrases. At each level, only one of those goal representations is active, and we have the flexibility that we saw when the robot drops the figure on its way to the speaker, because at each of those levels, all preconditions must be fulfilled before the intention in action is activated. And as an outlook, we now would like to do actual action planning as a sequence of different kinds of action phrases. And we have different kinds of action phrases when different objects are involved in the action. So, for instance, maybe the robot needs the red figure to place it on the speaker to hear a desired music, but we only have blue figures in our scene. But maybe we can paint those blue figures red so that we generated this red object that we then use to play the music. So then we have the first action, which is the red figure as a tool and the speaker as an affected object. And the different action phrase would be then the red paint as tool and the blue figure as an affected object. So for those, we could span the action tree, but we will not try to span like the whole action space that the robot can do. So for this actual action planning, we would like to reuse the belief structure to find a new action phrase and then form such a plan. But so important is that for finding a new action phrase that generates us, in our example, the red figure, we need to forget our previous action plan so that we can use the belief structure to find a different action phrase. So we need to have some kind of a working memory so that we do not forget our previous goals. And this is the state of the project we are working on right now. Good. So thank you for your attention, and I'm looking forward to your questions.